G'day everyone, how are you going? Another lesson here with our work in polar coordinates. We've done some work in our conversion between rectangular format for a complex number and polar format for a complex number. Our polar format's this sort of idea here. Our rectangular format is this idea here. So you should be good at moving between them, and you should see that that is exactly the same idea as the actual place. This point here is that and is that. Now if you were going to multiply some rectangular format complex numbers together, that really works in the way that most of your algebra works. Two brackets, multiply them together, make sure you've multiplied every part of it. Your I squared you're going to transfer into real numbers, and you'll come out with an answer somewhere around here, right? That's not so bad. But what about when we're given it in unsee format? We don't want to have to convert to be able to multiply, to then have to convert back. We want to work just in this format. So let's break from a specific example into our generic example, unsee theta. From unsee theta, what we're really wanting to do is, what's the shortcut when I get this? Two polar coordinates multiplied together. And notice that I've done R1 and R2, theta and phi I think it is. But it might be in this format as well. It might be the same point multiplied by itself. This of course would just break up in a similar sort of way. So let's work it out. Where are we going with it? Well, all I've done here is I've taken that and I've just expanded it to cos I sine. Alright? So it's really saying exactly the same as here, but I've expanded it out. If I bring the R1, R2 to the front, because that's all just multiplied, isn't it? Everything here is just multiplied together. So I can say R1 times R2 here at the front, and then I'll multiply these two brackets together. Okay, those two together. So can you see here I'm going to get cos theta times cos phi. And then I'm going to get cos I sine phi. This is going to be pretty long. Cos theta sine phi. And then here I'm going to get sine theta cos phi, and it's going to be imaginary as well. So I think this will squeeze in. I'll try and squeeze it in here. So it'll be I sine theta times cos of phi. And then the last part's going to be this one here, which, check this out, this is going to be I times I, so that's going to be I squared. Remember, that's going to be -1. So really I can get rid of the i's on that part and just be left with minus sine theta sine phi. Okay, so just make sure you're happy with that. I think I've got that okay. Now, once I've got that, well, now I'm looking at where I need to go. Once I've got that, I should be able to break this down into a little bit. And if you look at your formula sheet, you'll find that on the formula sheet, there's a couple of ways of working this out. Now, I've got to remember myself off the top of my head. Can someone grab a formula sheet and have a look? Have a look in here. I know it breaks down a little bit in here. Look in your formula sheet and see if you can see these sort of things coming up, and can we break them down a little bit. I'm going to cheat a little bit here because I've forgotten the little trick. Let me cheat. Here we go. Oh, there we go, of course, I see the trick now. What we need to do is just bring our real and imaginary parts together, okay? So if I have the real part here, cos of theta sine, cos of theta, cos of phi, minus sine of theta, sine of phi. And then if I go, I think I need to put a minus in there, I think. Let's see if this works out. Then that part there, I'll go no, I'm going to need a plus, this is not working out so well. Sine and then cos of theta and phi, and plus, I'm mucking a few things up here I know, cos of theta sine of phi. Now, have a look in your formula sheet. I think you'll find, I might be wrong, I think you'll find this will become cos of theta plus phi. Check that up for me. I think this will be cos of theta plus phi. And then this will be sine, it might fall off the screen here, of also theta plus phi. That might fall off the screen for you at the moment. Let me just move you across. Hopefully that works. And I've got R1 times R2 still out the front here. So I think you'll find that that'll break down. If I've got it around the right way, I would have to check the formula sheet. Then isn't this really just cos of an angle, or now a combined angle, plus I sine of a combined angle. So we end up with R1 times R2 times cis of theta plus phi. So it kind of breaks down neatly into something real neat. And the best thing about that is the fact that you can come back to the original here and say, well, what I need to do is multiply the modulus, the magnitude, the modulus of it, multiply those two together, and then I need to add those two together. And you've seen that we expanded out, we played around, we got it the right way around, we got this, we got here. Multiply the modulus, add the argument. So that's a nice little neat trick. You don't have to do this every time or convert to rectangular and then do your multiplication. You can just know the trick and do that. To put it in a, well, I mean really that's our formula right there, isn't it? That works for us right there. So hopefully that's made sense. I did get lost here, I had to check that up, but rather than converting back and forth to make it work, just understand I can multiply this by something else in A plus BI format and get my answers, or I can stay in polar format and recognise that this is going to work, and then I can get my answers in polar or A plus BI format, rectangular format. Either one is good. Hopefully this has helped. Catch you later.